morning, everyone. Call the meeting to order, and just note a couple of things for the record. Given the driving conditions in some parts of the state, some of our members are going to be listening to us online, and we are providing that they can send staff an email to ask questions or make comments, and so they will be able to participate in this hearing too. Secondly, I just draw your attention to an early introduction or pre-file bill in your packet from Representative Falk, and that is for us to consider the creation of a terrestrial invasive institute at the University of Minnesota. I think maybe we need to broaden the wording a bit, but I applaud Representative Falk for bringing that forward, and some of the testimony here today will be important for that. And with that, I'm going to turn this over to Representative Falk to arrange the meeting.
Well, thank you, Madam Chair, and thank you all for being here. I know it's kind of a cold and blustery day, so I appreciate you taking the time. And I do think that this will be a well-informative hearing, and we'll get some good information out of it. And the imperatives for this was when I attended Minnesota Crop Improvement Association's annual meeting a few years ago and had the opportunity to see Dr. Weiss present or give his presentation about herbicide-resistant weeds and the threat that they present to Minnesota agriculture, and some of the things that we should be looking at as potential solutions to address this issue before it becomes a crisis. And so with that, we're starting the discussion today, and Dr. Weiss has taken time out of his schedule to be with us. I know he teaches at the University of Minnesota, so I really appreciate the time that he's given us. It's really, I think, something we'll be very fortunate to have. And in addition, he also has Dr. Jeff, I believe Gunsolis is how Gunsolis is how it's pronounced, and he's worked with University of Minnesota Extension for a number of years and has a lot of practical experience to share with us as well. With that, I will turn it over to them, so if the gentleman would come to the table, we'll start with the presentation. Welcome to the meeting. If you would be so kind as to state your name and your official title for the record.
Yes, my name is Jeff Gonsolis. I'm an Extension corn soybean weed management specialist at the University of Minnesota.
Thank you.
Yes, and I'm Don Wise. I'm a professor in the Department of Agronomy and Plant Genetics, and I'm a weed ecologist.
Thank you. Please give us your testimony.
And members of the committee. An interesting opportunity I have today with working with Dr. Wise to talk about the development and progression of herbicide-resistant weeds. Notice I put a date of the 1980s. Okay, resistant weeds is not a new phenomenon by any means, but the 80s are a nice place to start, both for the agricultural aspects of Minnesota and also the fact that I started my career here 28 years ago, right about this time. And so I'd just like to draw your attention to begin with this one photograph. What you're looking at here is a common water hemp weed, and surrounding it are a lot of dead common water hemp weeds. Okay, we're having volume.
Turn the volume up just a little bit.
That's pretty good.
There we go.
Okay, as long as I'm not feeding back. All right. And you're looking at one resistant weed. Okay. Now, the resistant issue has been with us for some time, and I'm going to talk a little bit about the history of it. Let me go back. But I also want to know that I don't work just with Dr. Wise on these issues. There's a lot of people involved in the whole weed management issue. We have a series of people, IPM specialists around the state. We have regional educators that do a lot of educational programming on these issues and other pest management issues. And then we have faculty on campus in corn, soybeans. Jeff Durgan works in small grains. This is my counterpart. We came in the university about the same time working on weed management resistant issues. So we cover from cropping systems, which have direct impact on weeds, all the way down to the herbicides and other management practices that are involved. So there's a good array of people that we organize and work on some of these issues. But here's my first point about herbicide-resistant weeds. It can all start with one plant. And the significance of this photo goes beyond just the fact that this one plant, if left as it is, could produce about 500,000 seeds, okay, many of which would be resistant. Okay, the other point is that this was taken by a crop consultant who has 30 years of experience, and when he's in awe of what this particular phenomenon shows, then I have to respect the impact of that statement. Here's what we're dealing with. There's patches of weeds that are out in the field. They're selected and they become resistant, and we don't change our weed management practices. You can quickly go from a very small number of plants in a field to a great number of plants in a field without changing the management practices. And this has occurred in northwest Minnesota and other places as well, but that's where this photograph was taken. What we're basically dealing with is not a unique phenomenon. The entire South, this happens to be taken in Arkansas, Tennessee, Georgia, North Carolina, where I did my PhD, all of these areas, as well as the Midwest, is experiencing resistance phenomenon. This happens to be some glyphosate-resistant weeds, and this was taken by Jason Northworthy. It's in cotton, in case you're wondering why those plants look funny. Okay, but you're surrounded by another weed that we're going to talk about in a little bit called Palmer pigweed or Palmer amaranth. It's related to common water hemp, which is a weed we're dealing with in this state. But let's say the chances of resistance are 1 in a billion. Sounds pretty remote. But at this weed numbers here in these fields, at 74 plants per square foot, you have 3.2 billion plants per acre. Okay, so when you look at the numbers game, it's not nearly as remote as one might think. Okay, and when we get to herbicide use patterns in a little bit, you'll start to see how the resistance numbers game can progress. The other thing to deal with is, going back, is that as an extension weed management specialist and a professor at the university, I started my career in '86, and it was, as we'll see here, in the very early '90s, started discussing this issue. One of the things, and this is just a hypothetical development, but it's very real, we've seen this replicated many times, is because it starts out with one weed and progresses in clumps and moves around, it's easy to overlook the problem. Okay, but the issue is, like many biological phenomena, when we have exponential growth, it starts out small, seems pretty innocuous, and then by the time we become aware of it, as you can see with this figure, we move into a rapid growth and development of the issue. Unless we take alternate practices, it goes to be a large part of the population very quickly. This is a good example. This is an actual study with a set amount of weed seed in Arkansas. And this was with the Palmer pigweed, but this would be true of our weeds as well. They put this resistant glyphosate resistant weed population in the field, and you can see its progression by the second year. I think you can also see, if you look more closely, there's kind of a tailing off. It's following the pattern of the combine and harvest equipment. And by the third year, it's pretty much taken over the field. So the other issues we deal with when we deal with the resistant weeds, or weeds in general for that matter, is dispersal. Once they're in a field, there's many ways they can get around. Water. Example here is some flooding in northwest Minnesota a few years ago. Was moving some of the weed seed around, floated into areas where other people had done good best management practices but might be dealing with these weeds. Machinery, combines in particular, like I showed, wind dissemination, humans, animals. This wind, the upper right picture there, that's a kochia plant. That's an annual weed more common along the western border, northwestern border of Minnesota into North Dakota. But you can actually see, based on the pattern there, where that particular plant had tumbled. It was distributed by the wind, and you can see its exact pattern through the field. So along that line, one of the things that we do to try to have an impact in this issue and other crop management issues is, in conjunction with the Minnesota Department of Agriculture, we have a number of people that work in pesticide applicator training, commercial and private. And in these private sectors, a lot of our group for the last, well, it's been about 10 years now, have been doing IPM assessment surveys and looking at the response of our audience as we do the certification of various pest management practices. And as you can see, if one of the means of dispersal is equipment, etc., you can see the overall responses. And our goal, of course, is to see those all improve over time, but it gives you some of assessment of how the very real possibility of moving things along by harvest equipment, tillage equipment, etc., is laid out there right before you. So it gives us an idea of what's happening out in the state. Now, we're talking about herbicide resistance, but I think we need to make sure we have some definitions. And I also use this slide to call to your attention that the Weed Science Society of America, WSSA.net, has some very nice training modules on this particular topic, so that we get more people on the same page as to what we're really talking about. And what we're really talking about here with resistance is an inherited ability of a plant to survive and reproduce following exposures to herbicides that were normally once lethal to that particular wild type. All right? So it's an inherited ability. Whereas we do have weeds, common lamb's quarters is a very good example. It's inherently tolerant to many herbicide practices. And in this case, to glyphosate, it's often quite tolerant simply because it's not absorbed into the plant very readily. Okay, but the point is, it was in year one, and it still is today. Whereas the resistance is an inherited ability that's taken through time and changes in the aspect. Without getting into too much detail on how herbicides work and all the nuances of the chemistry, because I don't know about you, but biochemistry or organic chemistry flashbacks can be quite severe. I would like to keep you focused on the topic at hand. What I'm going to show you for later in the talk is talking about sites of action, different herbicides. These different large array of trade names that were out there are associated to each herbicide affects a specific biochemical site of action in the plant. Right? So, for example, glyphosate, the one that many are familiar with, is site of action 9. It relates to a specific enzyme in the plant that's inhibited by the presence of that molecule. So the site of action is but part of the whole mode of action process. Mode of action is how an herbicide works through its entirety. From contact, absorption, movement in the plant, and then metabolism and reaching a lethal level at that site of action. Why that's important is some resistance mechanisms are due to altering of this biochemical site of action. But as this, we're also seeing there are other methods of resistance that can occur, which does have an impact on how one would manage the weeds. So, for example, now if you look at an herbicide label, you would look, and they call them groups, but it relates specifically to the site of action. So the group 9 here is site of action 9. That's the glyphosate. Group 5 is atrazine. There are some herbicides that have multiple sites of action involved, and you can see that it's laid out. But the point of this labeling process is to help the person who's making the decisions how to diversify their sites of action out on the landscape to help reduce resistant weed development. So this is the shorthand. These are the site of action options available in corn and soybeans. All right. Some of these, those of you involved directly in agriculture, will relate to some of these sites of action, in some other means. Some of you, these are just numbers. But my point of showing you this is your finite set of site of actions in corn and soybeans. One of the points I'd like to leave with the committee and everybody in attendance is the probability of new sites of action, new technologies, is very remote. You can ask anybody in the ag chemistry industry. The last new site of action that came on the scene was this site of action 27 in corn, which is also called the HPPD or pigment inhibitors. Used in corn, trade names would be things like Callisto, Impact, Lotus. Various companies produce these trade names, but they all come back to the same site of action. So the first point is there's a limited or finite set. As we go on later, you're going to see that if we lose the use of some of these, so example with glyphosate, we lose a 9, or with ALS inhibitors from some chemistries, we lose a 2, you start to change this dynamic of your available tools. The other point is I know there's been some discussions and concerns about the development of some of the new herbicide-resistant crops, okay, that enlist and extend the dicamba 2,4-D resistant crops. What's really going on there is you have a limited set of herbicides, but what you're looking at here is you're taking the site of action 4, those are the plant growth regulators, that's the 2,4-Ds, that's the dicambas. And what's going on is the industry is creating tolerance or resistance in the soybean arena so that those can be used across both cropping systems. And the same is true for the site of action 27. So the plan over the next rest of this decade is that the 4s and 27s could then be used over in the soybean arena. Now, there's some pros and cons to that. It give farmers some new tools in that soybean set, but as you go on, if one of the main goals that I'm working with growers is to diversify sites of action over time, then they have to be cognizant of the fact that this is not a silver bullet. This is not the next cure to the problem. Management and integration of weed management tactics will be just as important now as ever. Okay. On the other hand, we have this site of action 1. This is a post-grass herbicide. Some of that is going to be migrating back over into the corn arena. So you can see that it's a limited, finite set, and what's going on in the industry then is changing resistance within the crop to take on herbicides from that where they were once lethal to. So the bottom line is that we have to recognize what drives resistance. In some ways, it's pretty simple. Selection intensity is using the same management tactic again and again. We need to diversify of the tools that we have if we're going to be using herbicides in the system. And the other thing is where I started is this is a numbers game. You're allowing the weed population size to increase in the seed bank. If you do that, it's just sheer probability that you're going to be more likely selecting for a resistant trait. It's going to exist out there. And we also have the issue is these things gain in population pollen movement. Okay? They don't move far. Okay, we're talking generally feet, maybe yards, to maintain viability, but it is one means of moving the resistant trait around. And like I said, showed earlier, one of our main issues is seed production and movement on the landscape. And as you'll see later, these seed can move in ways that one can't readily predict. So on the pollen movement aspect, this brings to mind when we talk about the 4 most common resistant weeds in a little bit, you'll find out that they're all cross-pollinated, so they have a lot of genetic diversity, and this is one of the common traits they have of the resistant weeds that we're seeing with the greatest frequency. So my goal as a weed management specialist is to keep in mind the realm and remind people what the realm is of what weed management is. You know, we don't increase yield. That's what breeders do. Okay, what we do is we preserve yield. Okay, and we'll show you some of the limitations of even our existing technology to do that in a minute. Our long-term goal is to deplete the weed seed bank, the reserves, and prevent other additions to the seed bank, because when we keep populations low, we have many more viable management options that we can use across the board, including herbicides, but including tillage and other biological practices. So our goal is to keep the seed bank low. So historically, in the 80s, before the 80s, and in that period when I came in 1986, keep in mind we had a lot more crop diversity, corn, soybeans, alfalfa, a lot more small grains. All right. We used mechanical weed control with a great deal of frequency, and a lot more of our weed control, our herbicides were done soil applied with what we call pre-plant incorporated herbicides. But in the 80s, the big deal when I was in graduate school that you always got grilled on is to make sure you knew everything about atrazine resistance. Okay, atrazine, when I came to Minnesota, we did have atrazine-resistant weeds. I think John Grunwald, you were involved in that work. But we weren't a big atrazine use state for many reasons. But the big thing is that it never really became a major phenomenon as a resistance problem. Mainly because, unlike I stated with the others, with the pollen movement, it wasn't a pollen-inherited trait. It was inherited in the seed itself. So therefore, even its rate of movement was limited more to seed rain, seed dispersal. But the biggest thing was the resistance trait also resulted in the fact it wasn't as photosynthetically efficient. It did not function as well as a tolerant or non-resistant weed. So when we changed practices, when we got together and did something else, over time, the frequency of this trait is not as prevalent in the seed bank, in the gene pool, simply because others could outcompete it. Now that changed in the 90s. All right. So in the 90s, we had 2 big events. Northwest Minnesota wild oat was resistant to the site of action number 1. That's kills only grasses, not broadleaf crops. And then in site of action 2, this is what a lot of you might know as ALS chemistry. It's really was one of those defining moments in my career, and I'll explain that in a minute. Came in 1990s, and you'll see the use and spread of it and the impact that it's had. But these resistant traits to date have shown no fitness penalty. In other words, even though we may learn to manage them, that resistant trait still resides in that gene pool. Okay? But the other thing is that the type of resistance was just a single point mutation in the genetics that resulted in resistance to this particular herbicide. So 1990, the trade name of the site of action 2 product was Pursuit herbicide. And I got grilled extensively on this. Farmers wanted to know everything about this product, more than anything else that I ever talked about to that point. And as you can see, by the mid-90s, it received 75% market share, 75% of the landscape in Minnesota, higher than any other state in the union. And the reason, when you start parsing out, was, and a lot of it has to do with the short cropping season, Minnesota could now decouple planting date from spray date. They didn't have to mess around with early season weed control. They liked that. And then, by mid-90s, ALS resistant was starting to take its toll. They went to the well too many times. The diversification, chemistry-wise, otherwise, was not there. And it turns out that these mutations occur very readily, more frequently with this type of chemistry. And so by the mid-90s, we were starting to have problems. We were having problems with common and giant ragweed and water hemp. So our first resistant water hemp was documented in Minnesota in 1994. That doesn't mean it didn't occur earlier. It means it's when it was documented, and I finally put it on this weedscience.org website. Okay, so it occurred, but then the thing is that what happened in 1996? In 1996, that's when Roundup Ready soybeans hit the market. Okay, and the problem was quote unquote solved. And the issue is that you're going to see today is the glyphosate-resistant weeds are the same spectrum of weeds that I just mentioned, and so they're really no different than when we left that pursuit era in the 90s. And so one of the areas that I've been educating on for the last 8-10 years is to really work with farmers to rethink these total post-weed strategies. I understand the desire to plant early and to decouple from other activities, but the weeds are really dictating our next move. So here's what I mean. Looking at data, USDA, Minnesota Department of Ag data, herbicide use. Let's start down at the bottom at 94, okay, before the Roundup Ready era. We were still putting some soil residual, the PPI pre means soil residual herbicides, down. They weren't necessarily dealing with all the ragweed species issues, okay? But as you can see, as the Roundup came onto the market, it furthers my point that we really do like total post-weed control in Minnesota because glyphosate only works post-emergence on weeds that are up. In 10 years, we went from 7% use of glyphosate. The technology really started taking off. By 2006, 98% of the acres were treated with glyphosate, and we had very little residual weed control. And the bottom line is just indicating that basically with the earlier 90s site of action 2 pursuit technology reached its peak in mid-90s at 75%, and it was reduced to less than 2% of the acres in that 10-year period. So we went from one heavy use of site of action 2 to site of action 9. So a lot of you don't farm, and also it's very cold outside, so I thought it might be nice to look at something green for a while, and so I'm going to go through these very quickly. Even if they're weeds, they're still green. But one of the issues with the total post system, especially now I'm going to highlight Roundup, is we're working in a field. This is a demonstration type thing we work with farmers on. This is out of southeast Minnesota with Fritz Breitenbach and Lisa Benkin and Ryan Miller and myself. This soybean field has a mixture of giant ragweed, water hemp, lamb's quarter that's susceptible to glyphosate, so it still exists. But look at the different timings. This is on very small soybeans, what we call V1, May 18th. All right. Now, by June 4th, if we let it go this long, it's getting pretty gnarly. That's a lot of giant ragweed, and somewhere down in there is soybeans. And then even 6 days, 7 days later, the weed populations really grow. This seems trivial, but if timing is of essence, both for control and the fact that if we don't have good control, we're actually furthering the possibility of resistant weeds, these timing issues in a total post system can be very severe. One rainout day, and suddenly things can get behind you. Here's where it matters. We just let these go through the rest of the season. They all receive just one application at these various stages in the soybeans. But I draw your attention to the V3 area. It's sort of that sweet spot of taking out most of the weeds that are up, because different weeds emerge at different times, without having too significant of impact on crop competition for the weeds on the crop. just 6 days later, that V5, you can see the difference that could have in yield. And actually, it's a harder sell, but if you start looking at the yield in V1, they're weedy, but actually there's less yield penalty by going early with your weed control than going late. These are not inherently obvious to a lot of our growers, so the seeing is believing aspect is part of this demonstration. But it also illustrates this time-labor issue that growers have to face as they put more and more, farm more and more acres. Corn is the same thing. Corn use rate, Roundup Ready corn came in '98. Okay, so in '96, about 73% of the acres were treated with a pre, and a lot of that was acetochlor, which is some people would know as harness or surpass. And you notice that by 2007, we were down to 23%, and 73% of the glyphosate acres. Same timing effect. Okay, this was taking a shot, again, where we just do one pass with the glyphosate to show the impact the timing has on weed crop competition and weed emergence. And you can see that early, there's some weeds, but that crop achieved 204 bushels. Less than 2 weeks later, a late application dropped it 170 bushels. And the reason that corn is short is because it sequestered those weeds. They were controlled, but sequestered about roughly 35 pounds of nitrogen per acre that was not available to that corn. So this dynamic with glyphosate also highlights the impact that we need to know more about weed crop competition, weed biology, and get that information out to our growers so that they're not hurting their yield, and also that these late applications don't further the resistance issue. Again, in surveys, what have growers been doing? This is fairly recent data, 2009 through 2011. You can see that post-emergence is still the preferred method of weed management, despite some of the timing issues that I showed you. And in corn, it's less. I think I had greater success with my corn slides than I did with soybeans, mainly because of the nitrogen issue and dealing with the binding and tie-up of that. So you can see that more went with a pre- and post type scenario in corn than they did in soybeans. But we're working on that. The weed shifts, some of the work we've been doing, demonstrating to growers they need to diversify their chemistry, they need to do their weed control earlier. This IPM assessment survey has, telling the truth, and this is a representative population, we're starting to have impacts in both corn and soybeans from that context. We need to do our weed control earlier is the message. Normally I don't like slides with lots of words on them, but the impact of this, when I found this quote a number of years ago, Jonathan Gressel, 1996, he was a very prominent worldwide researcher, scientist, and I respect what he says because his work goes way back to the atrazine resistance era and to the present. But this is talking about one of the issues that we're dealing with as far as prevention versus remediation of some of these issues. I like to be proactive and preventive in my weed management strategies, but I'll give you the quote. Farmers are loath to institute complicated preemptive resistant management schemes, especially if they cost more. Still, the best remedial strategy is to look over one shoulder and learn from the mistakes of others. When there's resistance somewhere to a pesticide under a similar cropping system, it's time to get scared. And not to say it hasn't happened here, therefore it won't. So when resistance appears and it's not spread throughout the population, further enrichment of resistant individuals in the population can be delayed. Notice he didn't say stop, but he said delayed. And basically, this in a nutshell is I think one of the greatest challenges as an educator is to how to present information to people so that they will be proactive rather than reactive in this strategy. Now again, what I want to focus on, why I repeated this slide, is this was in the 90s, our first big resistance issue. This is pre-GMO, and the point I'm making here is simply the resistance is occurring. It's representing a lack of diversification. Predictability is hard in these issues. The areas that I try to control in my programming is talking about cultural practices, other non-chemical practices farmers could do, frequency of herbicide use, and these different mechanisms of action that we talked about. All of these things have an impact on resistance. The unknowns, the harder part for us now, and where we're really learning that we need to know more, is more investigation of the biology of the weed species to find their weaknesses, what we can exploit, what we can't exploit to really have an impact on these weeds. Frequency of resistant biotypes. We just don't really even know a lot of the mechanisms of resistance, let alone the genetics of the weed species. So in a way, this is a whole new area of weed science that is really, some people are just starting to explore. But when you put all that together, it's hard to know how long it's going to take for resistance to develop. The other thing is that resistance can look differently in different ways. High levels of resistance are when you can put on 50 times the label use rate and still not kill it. Low levels would be in that 8 to 10x rate. And you may think that's very significant, but in the field it looks very different. But the atrazines, the ALS, the site of action 2, the group 1s, those resistance we could get on easier because they were very black and white, dead or not dead. Low-level resistance, that's one of the reasons Roundup was harder to get on top of. The site of action 9, I'll show you the intermediate responses. And you can see we have other chemistries, the 14, the site of action 4s, those are the plant growth regulators that we're concerned about. They'll sneak up on us. This is what low-level resistance looks like. If you didn't have comparisons in the field, you might not know what's going on. But you have everything from a fairly untouched plant that has been sprayed with glyphosate next to a dead plant, and then actually the injured plant is the wild card. Once a plant's injured, it's hard to kill it with another herbicide treatment. But the harder part is it's these that develop and actually go to seed and further enhance and enrich that resistance phenomenon. So the other problem with this, though, it's easy to misdiagnose this and say it was due to applicator error, it was too hot, too something, so that it didn't die. In the glyphosate era now, what we're dealing with resistance is different looks. See up in the upper left-hand corner, glyphosate injury, you see that the upper growing weeds are discolored, okay? They're not but it's not translocating to all the growing points. Again, you'll see in a field up in the upper right, some of the plants are dying, some are not. Or in the lower left, you see weeds where you killed the main growing point, but then you're just reducing more branches coming off. And again, the key is if these go to seed, you're enhancing the problem. And generally, your bioindicator in a field is patchy distribution like you're seeing in the lower right-hand corner. So progression of resistance in Minnesota, they developed very quickly with some, longer in others. Debating tolerance versus resistance slows this whole issue down. But now there's bigger concerns. Remember I mentioned before we grew from single to multiple species, and then we went to just one site of action, but now we have single species that are resistant to multiple sites of action. Okay? And then also with glyphosate, we're seeing multiple mechanisms of resistance within specific species. And that creates a high level of uncertainty in the field as to really knowing what our available options are in any particular field. So here's an example. This is taken from a poster that we're working off of that was funded by the United Soybean Board across the whole Midwest and South, but it's really highlighting. So on the left is common water hemp. So these are the big four in Minnesota: water hemp, giant ragweed, common ragweed, and kochia. Now, I listed on there, because of the little dots, the site of action numbers. And what that means is, U.S.-wide, these individual species somewhere have documented resistance to these specific chemistries. And you can see that water hemp is quite adaptable weed species. Now, the good news is in Minnesota, we only know of and have documented resistance to the ALS that started in the 90s, and then we stacked through multiple resistance and use with glyphosate, the 9s. So 2 and 9 for water hemp, giant ragweed, common ragweed, and kochia are the most common that we encounter in this state. But there's parts of Illinois where there's some water hemp that are resistant to, an individual plant's resistant to 5 of those 6 site of actions. That's certainly limiting your weed management options. And that's what this is trying to highlight, is when we look at the tools that we have from a chemical herbicide standpoint that growers have been using with great frequency. Let's just take the soybeans, because it's actually a simpler example. We're already resistant to 2 and 9, and especially in the post-emergence weed control area, that's putting more pressure on 14. Now, if you lose that tool, then that changes the dynamics in soybeans significantly. But the point here is simply that this is a finite set, and we can take away tools from this, our options through resistance. Mike O in Iowa State did a study where he just sampled randomly throughout the state, and I can't remember what his total number was, but I think it was over 1,000 plants. It was a significant number. What he is reporting is essentially to our south, a large number of the populations are resistant to the site of action 2, the next highest are to the 5 and 9, and then you can see some others coming on board. But again, of more significance, and the point I'd like to make with the slide is that 30% of the populations had multiple resistance. Okay, so it's not uncommon, and it can create some real challenges for a manager when we have multiple sites of action. So for example, I'm working with Fritz Breitenbach and Lisa Benken on a site in southeastern Minnesota, a giant ragweed site that's resistant to 9 and 2, and we were trying to establish Roundup Ready alfalfa, which basically means the giant ragweed's already resistant to the alfalfa, and the other next best tool for establishment is site of action 2. So we had to completely change our management strategies. In other words, we planted instead of in the spring when weed flushes were heavy, we had to plant in August to outflank the weed issue to get establishment. So it creates challenges. Distribution. Jeff Stockler, formerly of North Dakota State University with a joint appointment with University of Minnesota in sugar beets. He was a mapper, and he would basically highlight from reports, most of them not, black ones would indicate confirmed, the blue ones were just suspected based on discussions, field evidence, etc. The only thing I want to bring to your point is it's very hard for me to give you percent acres affected, but I can give you general areas where weeds problems are. Water hemp, okay, the giant ragweed and common water hemp, you can see the overlap. Common ragweed as we move north, and kochia on the western flank and into North Dakota. The issue has become great enough that with the help of the United Soybean Board is helping all extension weed scientists like myself in the Midwest and the South, really essentially working on a marketing campaign where we break out into areas things that need to be discussed. Like we're talking excuse me, to you today about weeding out resistance, knowing the weeds, knowing what's going on, what field tactics to use, how to better manage your spray applications, and really get down to risk management area. So it's really become a more unified messaging across states because it's a serious enough issue that commodity groups as well are starting to take action on this issue. The Minnesota Soybean Research and Promotion Council has been funding us for several years under a take control stream, which is very similar to take action. And that's where some of the research that the pictures that I've been showing you have been coming from, is from some of those demonstration and research plots. The goal to develop long-range durable plans for growers. And the key point that we're trying to make is also is integrated weed management is more than integrated herbicide management. So despite this heavy discussion on herbicides, we need to extend this conversation even further, and we'll take that in the next step here. The other things we talked about is, here's what we know about some of the weeds, but there's much more weed biology it would be nice to know. Weed biology plays into our strategies. We have early emerging weeds like giant ragweed and lamb's quarter. We have late emerging weeds. If they exist in the same field, one needs to be very cognizant of how one goes about that from a timing standpoint. Okay, that's why those timing slides I showed you were of significance earlier. So timing is very important and shows you the challenges of a total post situation. Duration of emergence is also important. The other thing is despite what I've been saying there, there's areas to exploit and areas to be concerned about. Seed production potential, those numbers vary, but it gets the point of what can happen. Okay, the numbers all across the board. But what we're trying to really exploit in some of our crop rotation studies is look at the giant ragweed. Its seed longevity is very not long-lived for a weed compared to, say, lamb's quarters. Hence the crop rotation discussion of ways to break that cycle so that we can reduce the seed numbers in the seed bank, as I stated earlier. Media has been of great help to us, and Liz Morrison did a very nice piece in Corn and Soybean Digest, and it was in November 2013, and actually worked with Lisa Benkin, who's a regional educator, extension educator. She put it on the line with some of her own tactics she's using on her farm. But these list some of the main things that we're currently promoting in the state to work with growers to reduce some of these issues. And I hope you see that a lot of these fit in with what I've been telling you to this point. My message is not received with great joy outstate. I think people have actually found me quite depressing. But, you know, here's what I want to share with you, is that this requires more planning. The ease of the glyphosate era is over. But it's easier than this. This is a real slide. This is University of Tennessee. I was down in Tennessee and Arkansas. I saw this firsthand. This is Palmer amaranth, Palmer pigweed. This is cotton. And they have field labor taking this plant out of the field by hand. Okay? Simply because they do not rotate, they cannot rotate their cotton acreages, and they were using glyphosate on glyphosate on glyphosate. They knew they did wrong, but they didn't realize how difficult it is to recover from that. But it's a good segue. So what does the South have to do with concerns for us? Palmer amaranth, Palmer pigweed is a relative of common water hemp. But I said earlier, as things get more prominent in the gene pool and more prominent in the seeds in the weed seed bank, there's hidden impacts. So this is cottonseed. This is coming from the South, and there may be some gin trash in there, which when they just separate out would have the Palmer pigweed seed in it, which is very, very small, about the size head of a pin. It's used in states up north as a nice feed source for some livestock, and then it goes through the rumen, goes through the cattle just fine, spreads out in manure, and takes hold. I worked in North Carolina for 4 years on my PhD, so I'm aware somewhat of Palmer amaranth, but it was never a significant species in the early to mid-'80s. That's what the herbicide resistance allowed it to get a big foothold. just like water hemp did in Minnesota. But now we're seeing it in Michigan, Indiana, and one small area in Wisconsin, and the main routes appear to be cottonseed for dairy and some implications from CRP. But there could easily be if you were getting your hay. We have a shortage of hay in Minnesota, forage from there. And once it's established, it can quickly move around. So what I've been working on is trying to just give an awareness around the state that to be on the lookout for this weed. It's a very adaptable weed. It's native to the desert Southwest, so it likes drought. Okay, it's very easy to misidentify it, but to emphasize the drought thing, and I want to be very clear on something here. I have to cover myself quite heavily at this point. For a field school this summer, I got some seed from a colleague of mine, okay, and on the right is Palmer pigweed, on the left is water hemp, both grown in the greenhouse, not under ideal conditions in June and July, but it really highlights two things. One is it likes heat, and two is it grows about 3 inches a day. So from a management standpoint, the folks in the South tell us that if you put on an herbicide, you need to have it on weeds that are 3 inches tall or less. Difference of 2 days can make a difference here of a weedy mess versus a fairly clean field. But when your plant grows at 3 inches a day, you can see where the issue is. So it's very competitive and a challenge for our current management practices. Costs of reactive strategies. I'm not good at these. I'm not very good at estimating acres impacted either. But looking from published results from the Palmer pigweed era, you look at some of the net increases in production costs dealing with this. If they let it get out of hand, we're talking roughly $20 an acre. I tried to do some simple math a few years ago and came up with a significant number of increase in production costs if we let some of these weed species get a hold of us. Resistant weeds, if we let things continue, obviously yield and profit are at loss, compromising our existing technologies. Okay, the resistance also will then replenish the seed banks, and we're definitely moving out of the era of the simplified weed control. And the unfortunate part of losing a lot of flexibility with glyphosate is you could really have a lot more flexibility in what your cropping system would be behind it, because it didn't have carryover crop rotation restrictions to other crops. The picture's just representing stress. So we need to rethink, okay? This is a slide I'm actually using a lot in winter meetings this year, and I want everybody to understand that we will not have new site of actions to work with, but my challenge to both the people I work with outstate now is what non-chemical tactics can we encourage farmers to adopt and will adopt over the next years, because we need to address this spectrum from more than just herbicides. We've talked mostly about herbicides today because that was the focus of the discussion, but crop rotation, inter-row cultivation, one of my big things is with the technologies we have, auto steer, guidance systems, etc., we should be able to take a lot of the time and labor out of cultivation. We should be able to improve our weed maps so we can put the right materials at the right place at the right time. Dr. Wise is going to talk to you about crop rotation, because the ultimate goal, again, there with the diversification is to reduce the seed bank. And continue my focus on early season weed control. That's been the big change over my career, is we drifted away from it to total post. We need to go back and focus on weed control earlier in the system. And just a delay of a week sometimes can make an enormous difference in what we're seeing out there. This is just a slide I use with my undergraduate students, but I can't emphasize enough the time factor and how that conflicts with the time labor requirements of farming in this era. So this time labor has been a big theme of mine. And my final point, and then I'll refer to Dr. Wise, is the weeds reflect our management practice, okay? And so what you see reflects the management practices we've been doing. And I also want to reemphasize that the resistance issue can start with just one weed. And so it's how we manage things through time that make a difference. So Dr. Wise,
Thank you, Dr. Gunselis, and we'll go to Dr. Weiss, and then when he completes, we'll start taking questions. So, thank you, Dr. Weiss.
Yeah, thank you very much, Chairman Paul. Great presentation, Jeff. Now you see why I wanted Jeff to make the presentation. Jeff has worked in this area for his entire career, and he's out on the cutting edge of these issues, working with producers and other groups across the state and really around the country and around the world. I've been somewhat on the side of this, thinking about the failures that Jeff is describing in terms of the number of tools that we have to manage weeds and how the number of tools really have decreased over the last number of years. I've been in the state 40 years, and during that period of time we've watched our rotations decrease in terms of the options that are available. And as we all know in this room, that we're basically down in each region of the state to maybe 2 crops. And statewide, basically corn and soybeans now basically across the entire state of Minnesota. 18 million acres of those 2 crops. And when you narrow it down to those 2 crops and then down to the number of herbicide families that Jeff described to you, that's a pretty narrow set of options. And the intensity of that selection pressure has never been greater in agriculture in North America, right? Corn and soybeans are now planted at the same time, selecting for the same set of weeds, and we're coming in with a limited number of tools, again, putting that selection pressure. And it's popped twice on us, right? As Jeff described, the LS group, came into place in both corn and soybeans. So millions of acres of corn and soybeans were being treated with the same class of herbicides. The weeds are going to win. Right? They have the diversity, they have the genetic diversity that's going to allow them to tolerate those inputs over time. Glyphosate, as Jeff described, came in and saved us from that disaster. But here we go again. We're using the same mechanism, the same tools, same selection pressure, and again we're describing that the ecology is going to win. The biology is going to win as you narrow down those options. So in your handout, we have this document. This basically describes another set of activities at the University of Minnesota that have been underway for the last 10 to 15 years. Again, those of us that deal with ecology and biology knew that problems were going to develop in this agricultural system. I mean, you could just predict it. When you narrow down and intensify the selection pressure, these pests, these weeds, are going to develop resistance to whatever you're doing, right? And it doesn't have to be just herbicides, right? If you use the same cultivation practice year after year after year, it's going to select for a set of weedy species. So in our agricultural system, certainly most of us are thinking about how do you add diversity? How do you get diversity back into the agricultural system? Why aren't farmers rotating more crops? And I think most of us in this room know why. Basically, when you're farming, you have to have plants in the landscape that are doing what? Plants that are profitable. right? And in the context of our agricultural systems, basically we've created a system where the framework of profitability comes off of a limited set of crops. Farmers could grow a wide range of other crops, right? We've seen it in the past. Why aren't they growing them? The market isn't there. So within this document, what we're trying to describe is a set of new plant materials that could in fact be developed at the University of Minnesota in partnership with the private sector to develop another set of plant materials that do in fact add diversity to the landscape, produce ecosystem services, but what do they have? They have the ability to produce some profit for the farmers that are growing these materials. All right? In the same way that we developed soybeans back in the 40s, right? If you look at the landscape back in the 40s, how many acres of soybeans were there in the state of Minnesota and the upper Midwest? Very few. All right? But in a public-private partnership, we have invested in the development of the soybean industry. All right? That's given this corn and soybean rotation that is very productive and profitable today for the Minnesota farmer. What about the next generation? As Jeff described, the odds of and the probability of a new class of chemistry being created in the next number of years that controls a wide range of weeds, has low-level toxicology, has good environmental characteristics. I think most of us that have been involved in weed science know the odds of that happening are very, very low. And if you look at the industry, the investment in herbicide development is very limited at this stage, because they know that the odds are low. So what are some of the other possibilities? We would argue that another set of opportunities would be to develop a wider range of plant materials that could be incorporated into the landscape. So what type of plant materials are we talking about? We have about 10 to 15 that are described in this document. Without going into great detail, we would basically suggest, as Jeff has suggested, early weed control. What can give you early weed control in the context of new plant materials for the landscape? Winter annuals. Right? Winter annual plants that could be planted in the fall would grow rapidly in the spring that would suppress many of the weeds that Jeff was talking about. Well, why aren't farmers doing that today? The options are really limited. But there are some real possibilities. To develop winter annuals that would develop in the fall, could grow in the spring, suppress those weeds. You know, another disturbance in that landscape, and suppressing those weed populations. Well, why aren't farmers doing that? In most cases, those winter annuals do not produce additional profit into the rotation. But there's some possibilities. Plants like camelina, pennycress, oilseed crops that could be planted in the fall with suppressed weeds, could be harvested in June, and then you could follow with soybean. In other words, plant materials that would fill what we call the brown spot in the current annual cropping system, the corn and soybean rotation. And by the brown period, we mean the fall through the 1st of May. That you would have plant materials that would be growing, that would give you ecosystem services, would hold nitrogen in place, and based on today's conversation, would also suppress those weeds. All right, another disturbance, another suppression of those weeds other than a chemical means. Right? But what would be the advantage? It would be a plant that you could harvest, right? Increasing the profitability of that rotation and extending the use of these herbicides that are so valuable in the current agricultural system. Okay. So what we're suggesting is that investment be made in the development of these new plant materials that would in fact add diversity to the agricultural systems, and do it in a way that makes it possible for the farmers to add this diversity to the rotation. And in my opinion, the only way to do that is to make it profitable. In other words, that they would be able to harvest a new product off of that landscape that would give those new opportunities to manage weeds as well as producing those ecosystem services. So with that, I'll stop and certainly would certainly entertain some questions. Chairman Paul.
Thank you, Dr. Weiss. I see Representative Kahn has a question.
Well, what kind of puzzles me is why it's taken so long to figure this all out. Long before I think I wrote something about this at the time that they were using these resistant seeds, but years before I was a legislator, one of the things I did was put antibiotic resistance markers into bacteria for genetic experiments. Fortunately, it was all confined in test tubes because it was a really easy marker to trace and use. And it was just like, as this started being used, one of the things I thought about was, this is just what I was doing in test tubes in my lab with E. coli bacteria, but fortunately all, except for an occasional spill, all confined to a lab bench and a refrigerator. So why wasn't this totally obvious that this was going to happen?
To either the testifiers?
To anyone.
Well, Chairman Falk, Representative Kahn, a couple of things. One is we can extend that from bacteria all the way to insects, all the way to disease. And we see it happening across the board. From the weed standpoint, we just go about it slower than your lab experiments do. But obviously, yes, the principles are the same. I think where the issue comes in is where Dr. Weiss was saying as well, is the interaction then with a short-term gain, seeing the advantages in year 1, 2, and 3, and not really thinking about years 5, 6, 7, or 10. And I think that has a lot to do with it, is the business plan of farming has so much to do with this interaction. And that's been one of my personal educational challenges as well, is the proactive versus reactive. So, yeah, you're right. The theory's there. The strategy's there. I think, though, as a biologist and ecologist part of my brain, I am somewhat fascinated, and I think we are learning some of the mechanisms that are occurring are things that maybe they occurred to Don. He might be smarter than I am, but they didn't occur to me. But the issue or the response is the same, diversification, etc. But I'd have to say we have the same issue, don't we, with children with ear infections, and we go through this at all spectrums. So I think it comes back to more than to human nature and economics, I think, are big drivers of this. And so it's one of those things that just has to be learned and then addressed as we go along. I don't disagree with you.
Representative Kahn.
Well, just following up, I guess it was even more obvious in the medical field. I mean, I never allowed my children, no matter how sick they were, to be given an antibiotic unless there was a positive bacterial result. And all of these arguments are, well, even if it's a virus, it will work against the subsequent problems. But, you know, part of the problems in medical applications. So, you know, you're right. It is exactly the same issue.
Yeah.
But this understanding that antibiotics don't do anything, the amount of antibiotics, I think, sorry, we're getting off agriculture, but but it is the same principle. The amount of antibiotics that have been dispensed against known viral diseases when they have absolutely no effect probably exceeds, antibiotics used where they're effective. So, sorry, it's a side issue, but the same one.
Dr. Weiss, do you have a comment?
Yes, Chairman Falk. It's Jeff and I were talking about this other day, and a number of the folks here in the audience can relate to this. Going back, in the 50s and 60s, going back a couple of years back from where Jeff was talking today, we had a set of herbicides, the triazines and the acid anilids that were used for many, many years. And I think weed science got lulled to sleep. As a matter of fact, when the acid anilids and the triazines were used in corn, they were used in corn for many, many years, and resistance didn't develop because we had a combination of two classes of herbicides that were active on the same species, right? So the odds of resistance developing was much lower. So when in the 90s, when we did in fact experience resistance to the ALS herbicides, many weed scientists, even though they know these principles, were really surprised and taken back because we had basically put a combination of herbicide families together where resistance didn't develop for the first 20 or some years. So weed scientists were taking a little back, even though they knew those principles. The first number of years in the use of two classes of herbicides, resistance didn't develop in the Midwest.
Thank you. Representative Hamilton?
Thank you, Mr. Chair. And doctors, thank you for your testimony. I'm just thinking here, as a farmer, what is our purpose, right? Our purpose, I believe, is to provide the consumer with a safe, wholesome, great-tasting product at an affordable price responsibly. We do our best with the tools and the knowledge, the resources, the information that we have available. We continue to work with educators, industry experts, to see if there's better ways to do things. I'm thinking back to the good old days. They weren't that good. Back in the 70s, when I was a 10-year-old kid walking beans, I would have told you that every single weed in that field was resistant. Back in the 90s, you're riding on a toolbar, if you will. Bunch of kids out there. Well, all the kids are moving to the cities, right? Fewer and fewer people out there. We talk about agriculture and profitability. Sometimes it's said with a little bit of contempt that for some reason farmers shouldn't be making money. I bet you that every educator is making money, right? I bet you every lobbyist in the room is making money. I'll bet you the cameraman standing there is paid to do what they do. A little bit, right? You know what? But why is it perceived wrong for farmers to make money? If you want to farm and not make any money at it, it's called gardening, right? I'm participating in an MS research study right now at the University of Iowa, and it's all about diet. And I'm taking a hard look at, what I'm consuming. You are what you eat, correct? But I found it interesting what she'd said. She told me I'm eating a lot of leafy greens, and I was a creature of habit. And she said, don't eat the same thing over and over and over again, because there's natural toxins in there as well, and it can build up in your body. She said, get a variety. I found that interesting. I think that we need to work collectively, again, between the industry professionals, between the educators, and other, stakeholders, to continue to search for those best management practices, those tools, and not just try to take away the tools that the agriculture has. Work together and bring forth solutions, and that's what I liked about a few of the slides in your presentation. Looking for solutions versus coming out. And there's a tendency to want to demonize agriculture. And again, we are trying our best to utilize the tools that we have available, provide the consumer with a safe, wholesome, great-tasting product at an affordable price responsibly. Thank you.
Well, I don't think I heard a question in there, and I appreciate the story, Representative Hamilton, and I don't think anybody here is demonizing agriculture, so We're trying to put some, information out there, which I think is very prevalent and very important, and should lead to some decisions we make in this state, because we do have a issue that's approaching. We've seen it happen in the southern part of the country, and it's knocking on our door.
Chairman Fockett, I would love to respond.
Dr. Weiss.
If I might. I certainly agree with you. As an agronomist, I mean, that's our job. Our job is to look at those things that are happening, and as I described, what we're proposing is that we do in fact invest in developing profitable options for farmers. And my argument is that in the last number of years, the investment in the development of new technologies, new ideas, there's been a lack of investment in developing those tools that will stabilize that system and make sure that system is profitable and is contributing to the development of the food supply for the country and the world. So I would completely agree with you. I think that the investment just in the development of herbicides, I think, is a mistake. I think investing in any single technology is a mistake. I think we need to take a broader view of our investment in agriculture and developing those tools that do meet those two outcomes, supporting our rural communities, our farmers, as well as the supply of wholesome and food that everyone can afford.
Thank you, Dr. Weiss. Representative Hansen.
Thank you, Mr. Chair, and good to see you, Dr. Weiss and Dr. Gonzalez. I want to go back to something you said about modes of action, or these points of methodology for the chemistry to take action on the biology. And I think you said that we've run out of options of the modes of action, that both in the public sector, which we fund, and in the private sector, that the weed science research isn't to find another point of attack. Is that correct?
Dr. Gonzalez.
Chairman Falk, Representative Hansen, yeah, that is correct. There are some agrochemical companies that are still actively exploring, okay? But one, not as many, and two is that it's really hard, and then even when you do find something, the whole development costs, all the other aspects of it, is very uncertain. And for example, then, I don't know if I stated it in the testimony, but Site of Action 27 was a late 80s site of action. And I think just biologically, if you think about it, we've covered just about all aspects of interactions with a plant, photosynthesis, protein synthesis, etc. So it's just not very likely. And I think the point in my own education is I really, although it seems depressing to a farmer, I don't want people to have the expectation of the next Roundup. That's a high bar to set. And so anything that comes off of that, I want people to manage their herbicides like it's a finite resource. That's really, and what I said, I believe, is absolutely true, that we don't expect new sites of action. You will see new trade names, but you won't see new sites of action.
Representative Hansen.
And Mr. Chair, to follow up on that, so Jeff, I can remember going out on those pesticide applicator training programs in the 90s and early 2000s, and we've been teaching this for a generation. So, and I like that you've got the data coming back, the feedback in terms of from the folks that are receiving the training that's going on. But how do we, so we're using the traditional extension system both to the commercial applicators and to the private applicators. And the tools are narrowing that we have. So if I remember correctly, when some of these products were first introduced, there were requirements for harborages or to put some diversity in the field in terms of mixing up the technology. And those were label requirements either from the seed companies or from for the chemistry. And just how is that still there? I mean, it's been a while since I've been out on that. Is that still there where there are label requirements for putting in different bands of seeds so that we have the diversity?
Dr. Gonzalez?
Chairman Falk, Representative Hansen, what you're describing to me, what comes to my mind is label requirements that fit more with the insect-resistant technology. There really isn't in that same kind of context for weed resistance in that same context. So the rotation or that some of those setbacks or refuge areas is more tied to the insect biology and how the gene flow works there, but not really with the weed end of things. The weed end of things, again, is more of a focus. What you'll see on labels is it has warnings about resistance, and it does describe some of these resistance issues. And one of the more recent positive things to help people is to put that site of action number on there so they can get it. Because before it was just an array of trade names that no real set pattern. So the part that you're recalling is really tied more to entomology type resistance.
Representative Hansen?
Mr. Chair, so that was BT corn and...
That is correct.
And one final question, Mr. Chair. So as a finance committee, we deal with funding, and we've funded Agri. There's higher ed funding that goes in there. Could you maybe talk about, I understand the extension side or just the research side, and Dr. Weiss, you provided this. What is the funding situation, or how do you receive funding, or where does the interaction for financing alternative management research?
Dr. Weiss?
Chairman Falk, that's a long conversation, but I do appreciate the opportunity to respond to that question. We keep talking about the fact that Jeff and I have been around for a while. I just found out the other day that I'm number one in my department now. That's the oldest faculty. So I've been around for 40 years and have watched the financing of agriculture research change dramatically. If you would just bear with me, I came to Minnesota as a weed scientist to work with the grassy producers in northern Minnesota to help them to diversify their agricultural system. As you know, Roseau and Lake Lewis County, it's a high-risk region of the state in terms of agriculture, at least it was at that time. They wanted a perennial crop or series of perennial crops to reduce the risk in that system. When I arrived in Minnesota, the Agriculture Experiment Station funded my research effort. If I remember back, I think I negotiated $30,000 in 1974 to support my research on a recurring basis, with support for a technician to actually carry out that work. Over the years, that support has gone to zero, right? So basically, we run our programs on grant dollars. In other words, we apply to LCCMR when granting opportunities for the AgriFund comes up. Certainly, we write the grants to try and bring those dollars into this work. So the continuing dollars have been really limited, and those of us that do not work on mainstream commodities, as most of you know, corn, soybeans, they have their check off and dollars are available to faculty and others to work on those. But when it comes to a crop like pennycress, I don't have a commodity group yet. You understand what I'm saying? In terms of where do we go and get those dollars? Well, we apply for federal dollars. We also go within the University of Minnesota. We have special funds there. For example, we've released varieties, so there's a a variety release fund. Some of those dollars have been supporting me to develop the pennycress, for example. So we basically are putting a wide range of resources together, but this is our difficulty. As you develop plant materials, what's important? It takes time. It's basically cycles of selection. And if you go back and think about how did the soybean industry develop in the state of Minnesota? There was a direct appropriation from the state to the University of Minnesota to hire a plant breeder that was in place for a long enough period of time to produce the varieties that fit into that agricultural system. That's the weak spot that we have today in our funding. That's the weak spot. If I'm going to develop a cover crop, pennycress, camelina, intermediate wheatgrass as a new perennial grain for the state of Minnesota, operating off whether you might be able to get 2 years of funding and then there's a gap of 5 years, you cannot run a research program and deliver products over time in that type of model. So that's really our struggle today, is that the dollars and it's not big chunks of money, it's consistency in those dollars to maintain a program that allows you to go through cycles of selection to produce those products, then that can be picked up by the private sector over time.
Thank you, Dr. Weiss. I'm just going to make one announcement. I was informed to the people who are watching live that the House feed will switch to the Civil Law Committee at the top of the hour. We'll keep this committee hearing going, and if people want to get the audio feed later on, they can do that. Representative McNamara.
Thank you, Mr. Chair. Dr. Gonzalez and Dr. Weiss, thanks for coming in. And I guess my question kind of leads to some of what you were talking about. It was interesting. You talked about the need for continuing funding, and we did recently in the last few years do the aquatic invasive species funding at the University of Minnesota. And I would argue already we're potentially seeing some real positive things. I see one of the things before us is a bill co-authored by Chairman Falk and Representative Wagenius, House File 1976. I'd imagine both of you are aware of that bill, and I'm just curious. You talked about how the need for continuing funding. I know specifically in my part of the green industry and agriculture, we have some regent professors at the university that have ongoing funding, so we have some opportunities already, and with some of the checkoff money and stuff, there's some opportunities. But can you just expand real quickly on what opportunities would be before us if we funded something like this terrestrial? And we've kind of made a commitment in the aquatic invasive species for it to be ongoing and not just be something a couple years, because I don't think that will work. I think you make a point, but I'm just curious, what do you think we as controlling the taxpayers' purse strings should put as far as taxpayer money? What opportunities would be there if we did something like this? And then, Mr. Chair, I have a follow-up question for you.
Thank you, Representative McNamara. And I would say, too, I appreciate your interest in the bill, and we're always looking for more co-authors, too. I think it's
Chairman Falk, I'll gladly co-author it, and I'll put in it's the first day of session to be on the bill. Thank you.
Thank you. And I would also say, too, that we didn't ask these folks from the university to specifically comment on this, but if they do have comments, it's hasn't been. We didn't ask them, or Chairwoman Ogenius and I didn't ask them previously for commenting on this, but we'll happily welcome any comments they have.
Well, Mr. Chair, I would think you could have, because they led in perfect to my question, and my question I had planned before they brought it up, so
sure. It
seemed to all work together, whether it was orchestrated or not.
Yeah, sometimes that happens. Dr. Weiss and Dr. Gonzalez.
Chairman Falk, thank you. And again, appreciate the opportunity to comment on this issue and specifically on the bill. Speaking from the standpoint of a weed scientist working in agricultural systems, in the term that's used in the bill is invasive species. That immediately leaves out the weeds that Jeff and I work on. because by definition, invasive species are in the context of undisturbed systems. That has been, at the federal level and the state level, a real challenge for those of us that work on weed management in disturbed systems. And we are almost embarrassed. I would say I'm embarrassed. Based on the limited amount of information that we have on these weeds that are so economically important that Jeff described today, we virtually know very little about the biology and the genetics of those species. Why? Because the dollars have not been placed in understanding those species, because they reside in a disturbed system and they do not receive any of the invasive species resources at the state or federal level. So we